lesson 43.
Judy started.
Today we're going to learn something called trigonometric functions.
Trigonometric what? Looks like a song. Trigonometric. Yeah, that's the chord.
Now, functions are a set of instructions, you remember? And trigonometry has to do with triangles and the relationship between sides and angles.
Yes.
So, these initially only work, or they come out of, right triangles. So, we have a right triangle, and these have names. So let's say the angle that we're going to be analyzing is here, and we're going to call it alpha because we use Greek letters for angles. If this is the angle, this side will be the angle opposite this angle. Does everybody agree that that is opposite? Because it's like in front of it. The one next to it would be adjacent. Adjacent means next to it, or next to something. So what is adjacent to the school, a parking lot, and the Peruvian embassy, I think, or something. But adjacent, who's adjacent to Seth?
Me.
Seth, you're not adjacent. You're adjacent to
Cuban.
Okay?
Someone, you're the opposite.
And this one, does anybody know what this long one is called? The one opposite the 90-degree angle? Anybody? No? Yeah? If you know it, say it. Hypotenuse. Thank you. Hypotenuse. Okay? Hypotenuse. If this has to be extremely clear. Let's say I have the same exact triangle, but now I use this beta. This is still the hypotenuse, because this one is still opposite the 90 degree. But now this one would be opposite. And this one would be adjacent. Is that clear? That which one is adjacent depends on which angle you are looking at. Okay? The 90 degree only has the one opposite end, and that one always is a hypotenuse. Is that part clear? Okay. So someone sometime figured out that there's always a relationship between the angle and the ratio of the sides. And they gave them names. So we have sine. The abbreviation is, it is not a sin. Please don't call it a sin. It's not Sunday school, so this is sine, okay? Even though it says S-I-N, and it could be pronounced as a sin, please, it's sine, okay? Cosine. This is not a cos, it's not a cos, not a cos. This is cosine, okay? Even if you see it as an abbreviation, you say it whole, cosine. And then you have tangent. You did not go to the sun. It is not a tan. It is a tangent. Okay? Now, these are expressed. It's always the sine of an angle. It isn't just a sine with nothing next to it. It's the sine of an angle. It is the cosine of an angle. It is the tangent of an angle. Okay?
Oh, tangent was one of our vocals.
And you say it like this. You don't say sin fishy. It is the sine of alpha. And it is understood, the of part, that this is an angle. Okay? Yeah, sine, fat lady, no. Cosine, beta. Cosine of beta. Now, this is not multiplying. Okay? You can't get rid of the alpha by dividing it by alpha. That's not what, this goes together. So if you just have a sine without an angle, there's something weird going on. And this represents a ratio. What ratio does sine represent? It represents the ratio of this opposite side here somewhere. Just realized it. There's an H here and an H here. Okay, hypotenuse. And the cosine would be the adjacent over the hypotenuse. And the only relationship we haven't made is the opposite over the adjacent. So right now it just sounds like a bunch of words and we don't know what we're doing.
Yeah.
We're going to look at something a little bit more concrete. Yes?
Is alpha and beta angles or?
Yes, they're over there, see? So let's start with, can I go over there
Sure, go ahead.
so I don't have to erase?
Go ahead.
Wait,
Am I
what
gonna
about
make
the
everybody
video?
miss?
I don't know. Huh?
What about the video?
I know, I'm gonna turn it.
Oh.
Okay, I'm walking.
Oh,
walking.
yes, you are indeed. Give me a second, I'm just gonna.
I'm walking
You're walking.
On sunshine!
this way.
Oh, yes, indeed.
Okay, so let's say I have this triangle. And I know that this angle here is 30 degrees. And I know that this side is, I don't know, 5, this one is 6, and this one's 8. I don't even know if that's possible, but that's what I give you, okay? What would be the sign, according to this, the sign of 30 degrees? According to that triangle. What would the sign be?
5/8.
It would be 5/8. What would be the cosine of 30 degrees?
6/30?
6/8.
6/8.
What equals?
Why over 30?
4?
No,
Never mind.
it can't be over 30. And tangent would be
6
5/8.
over, no.
6
5.
over 5.
opposite over adjacent.
Oh,
Okay?
yeah.
That is a relationship. Someone can sleep last night.
No, Mrs. because I don't have my glasses on, so I like.
Get tired.
Yeah.
Okay, is this clear?
Yeah.
It's really easy.
Yeah.
What is it that's not clear? Why is it 5/8?
Yeah.
Look at sine.
Opposite over.
Hypotenuse. Opposite of what? Of the angle, because it tells you which angle. So it's 30. What's opposite 30? 5. Over hypotenuse, 8. Okay? We clear? Okay. There's a way to remember, there's a bunch of ways to remember this, but you're going to have to memorize at least one of them. One is this one. People like to call it sokatoa. Sokatoa. It sounds like some, I don't know, Navajo word. Sokatoa.
Yeah, it does.
Or it could be like
Sokatoa.
sokatoa. Okay, so it could be that. And obviously-
Navajo tuition.
Yeah. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. It's all here, right? That's one way to remember it. Another way to remember it is, this is the one I learned in school way back when, with La Señora Ramirez, if she's watching. Some old horses can always hear their owner's approach.
Typical math.
SOHCAHTOA.
The same thing happens when you tell us if you move something to the other side.
Sokatoa.
Hey, bring it with you.
Oh,
That's gonna stay stuck in our head.
Okay, yes, I guess. So, we've got S, the same. Sine equals O over H, C equals A over H, T equals O over A. Does everybody see that?
Yeah.
Easy, right? I'm moving, I'm walking, I'm moving. I'm walking, I'm moving, I'm walking,
Okay, I get it.
moving. So,
I know this is well, that's not my pen, but yeah.
what type of problems are they going to give you?
Anything but math.
Some old horses can always. Yeah, I'm not
She's
gonna
walking.
hear their.
How many old horses?
Or you can just say some old humans can always hear. Some old humans are.
Okay, so now,
There.
Oh my god.
Old.
So old.
Miss, are we
So-
almost done?
how do you use your calculators? First of all, you have
With
to
our hands.
understand, or you have to check, that all your calculators say DEG for degrees. Does it say DG or at least DG?
Mine
At the
says
very top, it's gotta have like little tiny letters and it's gotta say degrees. DEG.
And if you don't
So
have
what
it, what
is
do
it?
you do?
mine says
If you don't have it,
DEC.
come to me and I'll change it because
That's
there's-
decimal.
just like distance can be measured in meters,
Oh.
inches, feet.
Miss, I found it. It says sin cos 10.
Nice.
So that,
What does
that's
it
so
say?
easy.
Sine.
Sine, cosine, and tangent. Sin, cosine. So, guys, you have to have it in degrees, right? Because if you have it in radians, you get a different answer. It's not incorrect, you just won't know it and you'll get weird numbers, okay?
Yes.
So it has to be in degrees. You can have degrees, radians, or gradients. We'll get into that later,
So
but right now it's just degrees. So everybody has that? So, if I give you, for example, what is the cosine of 45 degrees? You go on your calculator and you press cosine
Miss,
of 45.
Miss, can you help me find where's mine?
0.70.
It's fine, there's a D up there.
So
45.
Right, cosine,
Equals
0.70.
I need to know how much the cosine of 45 is.
0.70.
0.70.
I can't.
0.71.
Yeah, 0.70.
0.71.
Eso.
Okay. How about the cosine of 73?
0.29.
0.30 means.
Not 29 because
Six.
it's
Back.
0.292.
What's the sine of 140?
0.064.
Okay. What do you know? How about the sine of 13?
0.22.
The sin of 13
The sine of 13 what?
is
Okay. Tangent of 98.
negative 7.11. 0.12.
Okay. What do you notice is the difference between cosine, sines, and tangent?
10 is negative. The other is positive.
Not just the negative and the
It's
positive.
the opposite.
Bigger, way bigger.
Bigger. You will notice that sines and cosines are never, or should never, ever, ever be more than 1. Why can't they be greater than 1?
Because it's dividing. Bigger number divided by.
Because it's always a small number divided by the biggest, which is the hypotenuse, because the hypotenuse is always the largest side, right? So you should never get more than 1. If you get more than 1, you did something wrong.
Then
Okay.
how does it become negative?
This one, the tangent, we'll see that later. The tangent is opposite over adjacent. So, and because I did a 98, it's in a different quadrant. Never mind. Let's do 78. Give me the tangent of 78.
4.70.
Thank you.
Whoa.
Still, more than 1. So if you get something that's more than 1 here, you did something wrong. Okay? You gotta go back and check. Okay, now let's keep going. What if I tell you to give me the 4 sine of 63?
Oh.
What does that mean?
4 sine of
Good question.
What does it mean?
3 times, no, 4 times.
Okay, this means a number. How much is sine of 63?
Miss question.
Hold on.
0.89.
Oh, and there's a 89.
0.89. And there's a 4. So this whole thing represents one single number. It represents the ratio between the two sides of a right triangle, right? Is that understood?
Yes.
So if you have a 4 before it, it means you're multiplying the 4 times the number that this represents, the ratio that represents. Is that part clear?
Miss?
Yes.
And then we times that times 4. Or we leave it like that. That's alright.
The advantage of having a calculator is that you can write 4 sine of 63 and you can get an exact number. Yes.
Can you multiply 4 times 63?
Yeah, it's 3.
Why 4 times 63?
Since it's
yeah, I found it.
No, because this is not multiplying.
What?
Sine of 63
Oh,
is together
It
and
would be a
represents
different
one
number.
It is not. No. It's a good question. but don't do it. Like ever. This no.
I get it,
This is not 4. No, this is not sine times 4 times 63.
Can we
Like,
divide,
never.
miss?
No.
Miss, can we divide?
Huh?
Can we divide?
Divide what?
Get rid of 4.
Number 63 divided by.
No. Because it's not multiplying. Okay,
I
bye.
like it.
So what happens?
Wait,
if,
miss, wait,
Yeah.
one last question.
Yes.
If it's COS1, it would be
No,
0.
come on. It's cosine.
Cosine is 0.981, it would be 0.99999.
It's still less than 1.
No, but when you estimate it, it's gonna be.
No, it's still less than 1.
It's gonna be 0.1.
Please put 0.999 or put 9973. Do not take it to 1, please. Okay. You'll see a couple of years from now why not. Now,
Couple of years, no.
what if you have that sine of x equals 0.73?
Oh god, no.
You would instinctively say, well, divide by sine, right?
Yeah.
You can't do that because these go together. This is a function. So mathematicians have thought of this, and they said, well, every action has a equal but opposite reaction, right? So we call those inverse functions. And the inverse function for this one is called, very appropriately, sine to the minus 1. Okay? And it's called inverse sine. Now this does not equal, please, 1 over sine to the 1.
Why?
No. Because this is something else.
Then,
This is a reciprocal, not an inverse function.
then what is it?
So what is it? You'll see.
You move x to the
So
other
what
side.
you do to one side,
See, told you I was gonna
You
say
do
that.
to the other one. and if you try it out on your calculators, what happens? Inverse sine. How do you get the inverse sine? Shift
Yeah, shift.
sine. Okay? Inverse sine of 0.73.
Uh-huh.
Wait, miss.
Just that, miss?
Yes, just that. What does it give you?
I got
Why did
46.89.
46.89. So x equals 46.89 degrees, because what you're finding is the angle. Yes.
But what does sine do to the number? Like,
Sine is the name for the ratio. It doesn't do
46.90.
anything. It just tells you that you are dividing the opposite over the hypotenuse. Of what? Of the angle, which in this case you don't know.
46.
So sine tells you what ratio you're using.
and cosine is the opposite.
Cosine is adjacent over hypotenuse.
And it's still less than 1, right?
It's still less than 1. Because they're both being divided by the longest side. And when you divide something small into something big, it's always less than 1.
And what's tan?
Tangent is the ratio between the opposite over the adjacent.
So that can be more than 1.
Yes, because it can be two small numbers. And the bottom one can be smaller than the bigger one. Yes.
What is this used for, like, in real life?
This is
Yeah,
used
that's what I
for,
wondered because math.
this
we
is
didn't-
used for more than you could possibly think. This is used for flying. You can't fly without this. Because it tells you which direction to go. If this is used to calculate the inclination on roofs, for example. Because if they're not well calculated,
Slope.
they can fall on top of you if they're full of snow, or you can get water inside. You can get what do you call those? You have a lotera,
Oh.
Oh yeah.
a leak. You can get a leak in the roof because you didn't have the right thing. You can calculate distances with this. You'll see later on how to use it. Okay? It's used everywhere.
So
These are one
everything-
of the most useful things that you learn in high school. Is this?
Everything we learned in this
So
book is
everything else
used
is
in
useless.
life.
Everything we've learned is used in life somehow or another. Believe it or not.
Yeah.
Yes.
Swing multiplication.
Okay.
That's
Yeah.
Now let me finish this. So is this part clear? So what happens if you get, for example, the cosine of b equals? Could this be possible?
No. B.
The cosine of b is
It's
95.
like x. It's
No,
like
it's
x.
impossible.
It's impossible because it's greater than 1. So you know that can't possibly be. So you made a mistake, you copied it wrong.
It gives me
No,
a
it's right.
an error.
Yes. Now it's right. Okay? It's just so you don't come up during the
18
test.
points,
This
18.2.
calculator gives you a mathematical error.
What?
18.19.
18, so
Yeah,
you
that's it.
apply inverse cosine on both sides, right? And it would give you that B is
18.19 degrees.
18.19 degrees. Are we clear on how to use the cosine and the inverse cosine? And what they're both for? The inverse cosine is so you go backwards and you find the angle, because you don't know it.
Wait,
Okay.
So to do that, you only have to put that cosine minus 1 to
On this side.
0.95.
Uh-huh.
I don't know.
Because, no, because this one goes away and you're left with just the B. And then you just apply it to the number. Okay?
Would it be the same if you divide? Like for example, cos over
Cos
0.95.
what?
Cosine, cosine.
Cosines and
Cosine.
No.
No.
But
would
when
be-
you pass it to the other side. Okay.
Okay. The reason why you don't divide and you can't, or even shouldn't, is because these two are not multiplying.
I want to see some.
What are they doing then?
You are saying, I will now apply a ratio to the B, which is an angle.
Oh.
And the ratio is going to be the opposite, the cosine, the adjacent over the hypotenuse. And that gives me this result. What angle is it? So what is this? I'm applying a ratio to. Is everything, but can you imagine writing, I'm applying a ratio to every single time?
Oh my god, that's...
It's shorter to just write cosine. It's
Do
understood.
you need to put parentheses in it?
No, I put parentheses so that we could get rid of them. But it's like this, see? Without the parentheses. Like this. Is it clear? Is it clear that this is not a multiplication? It won't ever be.